The basic idea this week is to go back in time. First week, you basically built something. Yeah, we made you design something, but you just kind of sketched stuff on paper and then you made it, right? And that which you made probably didn't look a whole lot like what you started with on paper, right?
Yep.
Because the reality of trying to make something always changes what you thought you were going to do. Okay, that's the design process. That's what engineers are for. Okay, somebody designs something. It's usually not the engineer. It's usually an architect or somebody else. You get the blueprints and you have the stuff or the people that are making that design, and all these problems come up. How do we do this? This piece of rubber or whatever you're working with doesn't work for this thing you're trying to do. And it's the engineer's job to make it happen. You have to go from the design and you have to make it into reality. That's really what you're doing, especially as a mechanical engineer. So this next week we did the robots, where you're given a design basically, and then you're programming it to do tasks, and you have to modify that design. Okay. Now here we are making the design. I've given you what we call parameters. Your mission objectives. It's got to go 500 feet high. It's got to carry the egg. The egg has to survive. It's got to get back down with a parachute and hit at a less than 6.5 meters per second. Those are what we call parameters in the engineering field. And you have to make something that matches those parameters or exceeds them. To do that, we're doing both a build and we're doing the design. So you're taking the 3D program and you're making your rocket. And that's what you did yesterday. So you have your design. Now you're going to build it. Now, unlike the first week, you have to stick to the design that you have on the computer. You cannot modify it. Or if you do, you have to modify it on the computer to see what that changes. Because now you're dealing with something that if you change, you just decide, oh, I can't make these fins look like this, so I'm going to make them like, something else. A little triangle here. That's going to change the stability of your rocket. And the rocket may not fly anymore. It may not do what you want it to do. Okay, so you have to go back and make sure that the design program tells you that it's okay. Then you can make the changes up here. Okay, so now you're learning what it means to be more of a real engineer, where you're stuck. You can't just do what you want. You've kind of tried to do what you want, but everybody was struggling to get it to that 150 meters, right? Yesterday, hardly anybody could get it there. But now that you have it close, you have to do what the computer tells you to do as best you can, okay? And that's really what it's going to come down to. These rockets will fly as high as you make them now, because those little wobbles that you saw yesterday with your little rockets translates to 10, 15, 20 feet of altitude. If you don't put your fins on right, or you don't make your fins right, if it comes off and starts doing this when it's going up, it's not going to go as high as the one that goes straight up. Perfect, right? So the two things this week were design and build from the design, wherein you are constrained to do what you want, what the design tells you to do, okay? Which is very difficult. It's not easy, okay? But it is kind of fun because we get to launch them on Saturday. Okay, that's the basic thing. All right, let's get on to work now. Okay, so let's go over really quickly, right? So here's our basic rocket. We modified it from before. Obviously, the fins are different, okay? So we have the three elements. You're making two, I'm supplying the nose cone, right? You need to assign somebody to work on the payload section today. Okay? You cannot be doing everything yourself. So one person should be working on payload while another person works on the booster. Okay? The first thing you want to do is use your meter stick and use your design program to cut these things out to the right lengths. Okay? Because you should have on there how many centimeters long each one's going to be. Okay? So I'll give you a few minutes to do that. You're using your knife and your ruler. And what you want to do is be very, very accurate again. You don't want to start cutting and then have it like wavy or anything like that, right? The easiest way to do that is with this little black tube. This is called a coupler. In the end, you guys are going to put this is what holds the two stages together, right? So this fits in like this, right? And then that one will go on top of that one. See? So that'll be your whole rocket. And then when the ejection charge comes, it's going to pop out like that and fall back here. Okay, so how you use this to help guide you is you decide, say you want to make this 28 centimeters long. So you use your thing, you mark it at 28. Okay, that's here somewhere. I have pencils, so get a pencil. You mark it, and then put this on top of it, okay? And put it, and then just cut a little mark there, okay? And I just realized I have a better way of doing this. I'm going to give you a marking tube really quickly that you can put around the outside of this and then use that to guide you as you cut it around, okay? Let me get those in for you. So go ahead and mark your tube where you need to. Get pencils and all that kind of stuff. Yes, ma'am.
To open the program, you want us to use web server to find the correct program?
No. Okay, here, that's a really good question, guys. If you go to your rocket and try to open the file that has your ORK file on it, it won't work. You got to go first to the Open Rocket 15.03, open rocket, then open the file, okay? So because the computer doesn't know what to look for then, yeah. Whatever. Data on here, okay? So you should have your altitude, yes. I didn't have you guys do this yesterday, did I? No. Okay, so on your sheet, the one that it has here, let's put down what your design apogee is going to be, all right? And, if you can, put down your time aloft. That means how long it's going to be up in the air before it hits the ground. If you don't get that from that screen, you have to go to the simulation screen where it has the graph of the simulation, and just look on the bottom, that's the time. And see when it hits, it'll tell you how long it's been in the air. Okay? 30 seconds. So put those things on here. Yeah, this should be in the mid-30s or low 30s, something like that. Okay. Of course. Yeah.
All right, so the student's task was to build a rocket that has an apogee of 150 meters and then drops gently enough to save an egg that's on the inside of the payload chamber. So the kids had to do an equation to show exactly how high they need to drop it in order to simulate that in a tennis ball container. So we're using that as the payload tube. Right, so that's what we're doing now. We're testing our egg drop. So you guys need to hold your container up so that the bottom is at 2.13 meters, right there. A little higher. There you go. Are you up? That's. We need a little chair.
If you want to help you up,
a chair?
I'll help you up.
There you go. Good job, Jesus.
2.13.
2.13.
Well, that's, yeah. So just drop it? Yeah. Go.
Hold on just a second. Mr. Robnett, is the bottom of the tube at bottom of the tube? Okay, 2.13. So 2.13. All right. Ready? 2, 1, let go.
Thanks, buddy. Something okay.
Let's see.
Look at it.
I think you really should do that over again because you hit it from the side. It's going to come down straight.
It is. Because it'll have a parachute on it. That looks great. Let's try it one more time and see if it'll land.
You guys want to go first while I do this?
So you're going to need to bring your sheet so we know how high to drop it.
Alright, so since my partner wasn't here, he just sent me pictures of it because he had it. So mine is supposed to go.
All you're doing is one. Go with your hand. It's good. With your pencil.
Oh, Corona.
I just let it go, right? Yep. The map?
Mine was a setback. They made it.
I already did my map. Did it live?
That little ring, of which I had, I don't have it. Well, already okay. This little ring is going to go inside the edge that is overhanging, and then you're going to push it all the way down until it meets the other hook, the other end of the hook.
In the bottom of it?
It's got to go all the way down to the end. Right? Push it all the way in.
By the way,
There. So you see, the motor block is there. All right? This little hook sticking down is blocking it from going any further that way. Yes? See it?
From the top or
It's easy. It's better if you put it in from that side. Okay? If you have it on this side, it'll be in the wrong spot. Okay? There. We all good now? Okay. So this is what it's going to look like. Now, when you have it like this, see? It's there, it's being blocked and all that kind of stuff, right? Okay? Hold on, wait a second. When in doubt, double check yourself. There. What do you think? You're right. It should be that way. Good Lord. How many times have I done this? Look at that. That won't fit. That's why you double check. In a second. Let me finish screwing these guys up, and then I'll be right back. Put it about, I don't know, about an inch in on the top side, and then the other ring is going to go about an inch in from the bottom. Okay? Remember, the notch has to have the little piece in. So put them together without gluing first. Kind of line everything up so that you have the motor, the little clip is straight, right? And then what you do is you put glue all around the edge and then just move it over a little bit on top of the glue, okay? So you get it all lined up like this, right? See how that's a little out of center? So I just kind of move it over until it's nice and straight. Okay? And then I put a line of glue on one side, push it over, and then put a line of glue on both sides again. Okay? So again, we can never use enough glue. This part of the rocket takes the most pressure, most force. Okay? So it's got to be really strong. That's why we're using the epoxy. Okay, so when we're done, you have this. And what I'll do is I'll come in and we'll just double check we can put the engine in. Just like that. All right, any questions? It's good. So let's go ahead and glue it down. So just put glue over here. Push it. Yeah, that glue. Yeah, we're using the same glue all the time here.
What glue is this?
It's epoxy. It's the strongest stuff you can use. And you put some on both sides, right? Nice and straight. Okay, then you're going to insert it into, is this your booster? Okay, you're going to put it into your booster. Okay, so if you have kind of a wavy line on your booster, use that for your end, okay? Because you want to have a nice smooth line where you have a junction with your payload. Okay, so first make sure it fits in there. Just kind of push it in there nice and easy. Okay. See how it's a little tight. There we go. Started.
What are you doing?
Okay, and you're going to have to play around with it because the glue's still a little wet. You want the engine to come out about, I don't know, about a ½ an inch or so. So that's where it should line up. Okay? So once you've got it so it looks like it's right, take it out. Easier said than done. Okay? Make sure everything's lined up again, and then use your stick to put a ring of glue around where both of these things are going to be. Okay? You don't have to be perfect. Just put a bunch of glue in there. But don't put it all over. Then don't put it on here. Put it inside the tube. And then push this in until it meets it. Make sense? Okay. And that way we should have the whole engine ready to go. Okay? And then this dark thing is called coupling. Okay? And then you need a little piece of wood, this thing here. And if you got glue left that you haven't used, you can, what this little piece of wood is like a patch. It goes over the hole. Right? So just put some glue on there and put that over the hole. That's your first thing. Okay? If you don't have any more glue left, just wait on that part and do it next. Who has it? We have a lot of Angel, yes. Follow what I'm just saying. Okay. Robert? Yeah, hey guys, give us an extra. You have extra questions? Okay, we're making what's called a bulkhead. Okay? Okay. The bulkhead does two things. Very important. First, it holds the two stages together. That's why it's called a coupler also. So one end's going to go inside the part with the motor, the other end's going to go inside the payload thing, right? The other thing it does is it partitions. It has this thing. We're going to put this thing in one end, right? And this thing here makes a barrier. So when the engine blows or pops the two stages together, that the hot ejection gases don't get in the way of the egg. They don't go in and fry all of your padding and everything, right? So we make a barrier right here with this wood. Okay. And then you have this little hole here, and the wood that we put over the hole to patch it, because I don't know how to make one of these things without making a hole in it. What we're going to do with that is we're going to put a hook in it. Okay? And the hook is where we're going to put the tether that holds the two stages together. So when they pop apart, they stay together with the parachute pulling down. Okay? That's the thing. All right, so here's how you do it. If you haven't already done this, you need to do this. Okay? Secondly, you're just going to glue, and see how it kind of flops around? So you need to use a nice heavy amount of glue and glue into one end, it doesn't matter what end, this part. Okay? Last but not least, you're going to take eye hook that I give you, and you're going to screw it into the wood there that I gave you. And you're going to put it all the way in. All right. And then you're going to put some more glue around that just to make sure that it is stuck on there. All right? So this to here to there, everything glued solid. It doesn't have to be around the end, it can be in a little bit. All like that. That's what the bulkhead looks like. Everybody got that? Great. All right, when you're done, you're done. That's it. Then we'll take a break. Okay? We'll come back and we'll. That way, all we have to do later is fins and parachute. Okay?
Wait, do we have any?
And you need to figure out the size of your parachute, right? So it should be 3 times because you're going to have the twinings that goes across the diameter, is that the word, of the parachute. You need the same length on every side. parachute drops. Okay? So, I gave you guys some tape so that you can mark the 6 points of your hexagon. Yes? Yep. And you have a, what do you call that thing? Is that a protractor?
Yes.
Do they have those?
Oh, no.
To figure out your angle?
Okay, so from the center of
A little map.
yes. So we're making a hexagon, right? Because
But you don't want to get the like the,
we'll start, once we know what their diameter is, we'll start, I'll start going around and doing all the point.
okay.
But let me do a quick parachute inspection. He was hoping I would.
Is that right? Like, just figure it out, draw it out. You guys are smart.
Yeah.
No, we're not.
Yeah, they are. Don't let them
You
fool
are.
Okay, so principles of parachute 101. Okay, why do we use a hexagon? Anybody know?
Because it has tie points.
Okay, we use a hexagon because nobody in this world can draw a perfect circle. All right, if you can't draw a perfect circle and you have a circular parachute, it's going to be kind of lopsided or not open very well. But it's pretty easy to make a very close to perfect hexagon. Okay, so a hexagon, when you put it all together, is almost a circle, right? So that's why we use hexagon. That's why we're doing this. They're easy and they're easy to make. Okay. So here you have enough room to make about a 23-inch diameter hexagon. And I think everybody in here was around 18 inches, right?
Yeah.
Anybody more than 18 inches on their parachute? How much was yours? 48 is well, 48 is a centimeter. Yeah, 48 centimeters is about 19 inches. So you're okay. Yeah. Yes.
We got 22.6.
Is a big parachute, but I said we could get anything up to 23, so we're okay. All right. If it doesn't work, we'll go to 21.6. That'll be all right. All right, so everybody quiet down, please. Okay, Ms. McKenna is going to give you the actual directions for how we do this. But the idea of the parachute, of course, is we're slowing it down as it's coming down, right? So it's going to come down at a nice, even pace, but it's not zero. It's 6.5 meters per second, which is pretty quick, actually. You know, that was that 2.1 or whatever meter fall, right? That's why if you ever do skydiving, has anybody ever skydived before?
I want to.
You can, it's not impossible to do it, it costs some money, but that's what they test you. You actually have to jump off of, I think, a 2.5 meter or a 2 meter platform onto like ground. So that simulates your landing even with a parachute on. So that's how we get that idea. So you actually do that when you do parachute training. Okay? And there you are. So 6.5 meters per second, about the same for what you want. And then your little leg should be happy. Okay? Now the idea of the parachute shroud lines, what we're going to give you is most parachutes that you guys have seen, you have the parachute. I'm going to make it, there's my hexagon, right? See? Not a bad hexagon, I'm terrible. So here's your diameter, right? So if this is your diameter, and we're going to make a shroud line, how many shroud lines are we going to have? 3 is the correct answer. Because what we're going to do is we're going to go straight through 2 points of it and out the other side. And then we're going to do the same thing on this edge and then the same thing on that edge. Okay? Everybody see that? Everybody looking? Okay. So you have 18 inches from here to here, and then you can have another 18 inches over here, and another 18 inches over here. So how long is this line from one side to the other?
36. No. Never mind.
18. 54. Right. Good job. Who said 54? That's right. I did. Yeah, 54 is what you're going to use. Okay. Now, why do we have the spring going all the way across the middle? Do you guys know? Why not just attach the string right here?
It gives it support.
And another string over here. Why?
It gives it support.
Exactly. This is strong. You go all the way across, then it's distributing the force all the way over the top of the parachute. If you put it here and you let it go, they pull right out, because this stuff really isn't the strongest stuff in the world. It makes good parachutes, but it'll pull out if you try to attach it to the little vertexes. Okay. So we're going to go all the way across, and that's how we're going to lay it out. So what Ms. McKenna was saying is, we'll give you the 3 strings that is 3 times your diameter. So that's what you got to tell me. I'm going to come around with a string, and you're going to say, I need 3 that are this size. If it's 18 inches in diameter, you need 3 strings that are 54 inches each. Okay? And then you're going to lay them out. That's where she's going to show you how to use the protractor and the tape to lay them out. And then you're going to cut, and then we're going to tape them, and we're going to be happy. All right? Questions? Okay, I'm going to start going around and giving you guys your strap lines.